vaccines, testing, and everything related to um, both testing and vaccines. We started our first series, first show, we talked about vaccines, the importance of them, why it was important, why people needed to understand all those type of questions. And we started it by saying, listen, we just want to give you the information. And tonight we're going into our second show saying the very same thing. We want to give you the information so that you are informed. I'm Tina Evans, Communications Officer with the Bermuda government. I'm delighted that you're joining us this evening. I have with us this evening the Chief Medical Officer, Dr. Oliayenke. Did I get it almost
Ayo
right?
Oyiloye.
Oh, see, I shouldn't have started.
Tini, it's fine. It's fine. It's Ayo Oyiloye.
Oh, there you go. Now, tell everyone that instead of my poor pronunciation, you allow us to call you Dr. Ayo.
That's fine.
Call
me Ayo.
I thank you. Chief Medical Officer. Also with us is Sister of the Soil, I call her Dr. Karika Weldon. Dr. Weldon, who we know. We also have with us Daiwan DeRosa. And joining us for the first time, all the way from Ghana, we are so delighted to have with us Dr. Noab. And we are delighted, Dr. Noab. Can you put your microphone on for a hot minute?
Yeah, thank you.
Yes. And I promise we won't stay for 4 hours. What time is it in Ghana?
It's 11:02 now.
Okay, we promise. We'll get you to bed at some point. And I want to thank my team at the Department of Communications and CITV. We're going to get right into it. Tonight, we're going to talk about testing. There's been so much discussion from the students, from the schools, and also from adults and travelers about testing and the importance of testing and why do we have to test so much in Bermuda and the types of testing. And then we'll talk a little bit with Dr. Noab about vaccinations for the 12 to 15-year-olds. So that's how we're going to work it tonight. Daiwan DeRosa, the epidemiologist with the Department of Health, will talk as well and give us a background of what is going on in terms of testing and how we are doing in testing in Bermuda. So we're going to start out right away with Dr. Ayo. We're going to start with you as the Chief Medical Officer to share with us about testing and tell us why we got to test so much.
Okay. Right. Okay. Right. Good evening, Bermuda. My name is Ayo Oyiloye. I'm Chief Medical Officer. My background is in medicine and public health. And my area of special interest is in healthcare, public health, and also in health protection. That's bugs and nasties. For everybody else. So what I'm going to do today is tell you a little bit about testing and a little bit about the science behind testing. And before I start that, I would want to have a quick recap of what we know about the body's immunity, and that sets us off into how we test and why we test for the things that we test for. So right. So if we make a start, let's see. Okay, right. So this is I have adapted the slides from Dr. Ascott. So I think it's very educative and very informative. So that I just want to run through that very quickly. So if you've seen this before, just think of this as a quick refresher into into the body's immunity. Right. So how does immunity work? Okay. Right. So the immune system in the body is basically like an army or a police force. And there are different parts of the immune system that all work together like a defense system for the body. And what in this case, we're talking of the adaptive immune system, how the body responds to various insults to it. So we have the helper T cell, that's like the general that controls everything. The antigen presenting cells, they are like our detectives or our intelligence officer. And we have the killer T cells, like the sniper units, and also the B cells, who are like basically our policemen with who do the arresting, and they arrest using the handcuffs, and those handcuffs are antibodies in the body. So basically, what does the immune system do? It's about parts of the body that recognizes what is not you, or what is an altered version of you. And right from the time you are inside your mother's womb, that system begins to build, and it recognizes you by going through a school in the thymus. That's just at the neck, the organ in the neck that then allows those cells to recognize what is you, as opposed to what is not you, or what is an altered version of you. So the antigen presenting cells, as I mentioned earlier on, understands that. So they're like the detectives looking all throughout for your body, looking for anything that is not you, that includes viruses or bacteria, or an altered version of you, for example, cancers. So what happens when you get infected? The virus, remember our gunman from Ramon's presentation, which represents the virus. It's like an intruder breaking into your house. Once the intruder breaks into the house, the detective sees them and catches them and say, oh, right, this is an intruder coming to the house, like an alarm system. And what it does, immediately tells General, we have an intruder in the house. What do we do? The general tells the policeman, right, go ahead and arrest this person, get some handcuffs and arrest this person. But before you do that, and then tells the snipers, go and shoot him down and kill him and get rid of him. Before you do that though, make several copies of yourself so that you have a whole squadron of policemen or whole squadron of snipers, which are memory T cells and the killer cells, and then attack this person. Again, it takes 2 weeks for this to fully develop. So the virus stands no chance, basically, with the body's system. However, as we said last time, this whole system takes about 2 weeks to fully work. So our gunman is the virus. And remember, Ramon talked about the spike protein being the heart, and in this case, the burglar is wearing a green hat. The fat that covers the virus is basically the coat of this guy. And for the purposes of our illustration, the genetic material that is inside the virus is the gun, because that's what is actually causing all the harm that we have from this virus. So remember that it's just that simple. Those are the three main parts of most viruses. So going now into testing, how do we test? So there's three main types of testing. So basically, the nucleic acid amplification test is basically looking for the gun, or the antigen test looking for parts of proteins, which could include the heart, or antibody tests, which is basically tests that check if you have handcuffs to this burglar in your system. So what are nucleic acid amplification tests? So this is a broad term to cover different types of tests that used to look for the gun in our virus. You probably will have heard of PCR tests, because that's what we do on island. And basically, what does it involve? If you remember from secondary school biology, you have a cell that has different parts of the cell. What you do is once you collect the sample, it's broken down to remove the nucleic acid parts of it. So that's the gun in a virus. Everything else is waste and is removed. So what we do is we make several copies of this, and then we detect those copies of the nucleic acid. And that's what happens. Essentially what it is a bit like a powerful camera. The closer, the more of the stuff you have, the more of it you can see, the less the amount of amplification you need. But if it's so far away from you, or there's so little of it, you need to amplify it several times before you can see it. And therefore, if you hear about cycle thresholds, basically think of it as a number of times you need to zoom in before you find the nucleic acid or the gun in the virus. Right. The other types of tests are the antigen tests. Remember we talked about the B cells being the policeman in the body, and also the policeman having handcuffs, which are the antibodies. So what these tests are is they have these antibodies, the handcuffs, produced, and they look for the green hat or a part of the virus in a sample that we collect. So if they find the virus in the sample that we collect, they cuff it, and because it clumps together to form visible clumps, we can actually detect that it's there. So it goes like that. You have the virus here, the antibodies. Once you mix it up in the system, they all clump together and becomes visible to the naked eye. And it looks a bit like this. It's similar to what you find in pregnancy tests. So you take the swab, put it in the primer and drop it in here. Wait a few minutes. The control comes out as positive. And if you have a positive sample, the test, the T, comes out as positive. If it's negative, only the control is visible. So that's what the antigen test is basically. Antibody test is the reverse. So remember we talked about handcuffs. What happens in the antibody tests is that you're looking for handcuffs. So you have purified virus or purified parts of the virus that you then look for, and you put that in samples of the blood. So instead of you having looking for instead of you having the antigen from the person reacting with the antibodies from a test, is the reverse in this case. You have the antigen, purified form of the virus, looking for handcuffs in the system. So it's just a flip side of the antigen test. And that's what it is. Take a little bit of blood, just a tiny little bit of blood, and then you look for handcuffs in that sample. And that's basically what it is. So what's the difference? Why do we have so many different types of tests? The nucleic acid amplification test, or the PCR tests, polymerase chain reaction tests, are actually very, very sensitive and very specific. And what that means is that if they say you have, if they say the virus is there, it's most likely there. And if it says the virus is not there, it's most likely not there. The disadvantage of this is that it takes time to complete. And it requires quite expensive equipment to be able to do, and you need very skilled staff to be able to do it. What about the antigen test? It's actually very quick, very easy to do. It's relatively cheap, but the disadvantage is that it's not as sensitive. So it's not all the time that you have the virus present that is able to pick it up. And in many cases, you need to have a confirmation after you've done the antigen test. What about the antibody tests? It looks for previous infection. Remember, we're looking for evidence of handcuffs, and it takes 2 weeks for handcuffs to form. So that's the antibody test, and that's what exactly it's looking for. So it looks for evidence that you have handcuffs in your blood system. And then it can tell you that you've been infected in the past, not necessarily infected at the moment. The disadvantage, though, is that if you have a positive test, it needs very careful interpretation because there are several parts to it, and the timing of the infection plus the parts that you're seeing would impact on the type of interpretation that you give to the results that you get. So it's a fairly complex text to interpret, and that's why it needs to be done under a doctor's prescription. Right. So we've talked about the different test types now. What I want to talk about next is the different samples. So some of you who may have had tests done will have had different types of tests done. And so what I'll be going through the next few minutes is exactly what the difference is between all the different types of samples. So we have the nasopharynx sample, oropharynx sample, buccal, self-administered mid-turbinate swabs, and saliva samples. Nasopharynx, this is the stuff you get when you have traveled and you go to Peru post office and you need to get the test done as part of your travel testing. What is done is that a swab is inserted down your nose to the back of your throat and to scrape the little part of your the back of your throat, because this virus has a predilection for the back of the throat. So it's almost always there, and you can oftentimes get it. So that's most likely, that's for all intents and purposes, that's where you're most likely to pick up the virus. It's not affected by what you've eaten or what you had to drink. So that's actually meant to go for that. The alternative is a buccal swab, and that is basically taking a swab from your cheek. Basically what you do is you wash your hands and you take the sample and rub it down the cheek a couple of times, both times just below the gum line, and put it in the sample and send it to the lab. That's also obviously less invasive. Trouble with it is that if you eat or drink or smoke 30 minutes before that test, it affects your results and it doesn't give us accurate results. So the next one is the oropharynx, and this is probably what we use. This is what we use for children or for adults who've had surgery on their nose, so that it makes it difficult to collect samples. And basically what we do is you depress the tongue like that, like so, look for the tonsils and rub the swab on the tonsils, and you have your samples. The other type of test is the self-administered mid-turbinate test, and some of you may have done this. It's very similar to the buccal swab, except that this time you push you wash your hands, take a swab, push it as far back as you can, then rotate it a couple of times, go to the next nostril, rotate it a couple of times, put it in your tube, snap, and send to the lab. And that's it. The final type of sample I want to describe is the saliva samples, and hopefully some of you will have seen this. What it is a spit test. You just take a little bit of saliva, it's about a ml of saliva, and you put it in this container over here, pack your forms and label it correctly, and put everything in a bag and send to the lab. Like the buccal swab, you should not eat or drink or smoke 30 minutes before, but it's a fairly robust test that we do for detecting this virus. Right. So where do we test? We have fixed testing sites at Bull's Head, the Star of India, and Penrose Wharf, and this is all on the website. You can have a look at this. If you go to the gov.bm website, it tells you where this is. Occasionally we do have pop-up sites but we announce that well in advance so that people know where those pop-up sites are going to be. How do you get tested? If you go to gov.bm, this is your landing page. You go to get tested for COVID-19. You click on that and it takes you into this. You can choose the sites that you want to get tested, choose the date you want and choose the time and book. And it's that simple. Okay. What labs do we have in Bermuda that are accredited to do COVID-19 tests? We have the MDL lab, the Helix lab, the CNS West lab, and the hospital lab. Those are, and my colleague, Dr. Weldon, will be telling you a little bit more what happens behind the scenes after you've done all that work, what happens behind the scenes. So before I go, I would like to remind you why we do the testing. The best way to understand, to manage an outbreak of COVID is to, in the words of the WHO Director General, Dr. Tedros, is to test, test, and test. And that allows us to know what is going on with each person. Remember, each test tells you what's happening at that point in time. It doesn't tell you what happens the next day or the day after that, but it tells you what happens at that point in time. And that's why it's important to test and test and test. And Bermuda is one of the exemplars in the world in the amount of testing that we do. So a little bit about our testing figures. We've conducted well over 250,000 tests. Most of them have been negative, about 1% have been positive. And my colleague Daiwan will tell you more about that when she gets there, gets to her turn. So remember what we said about the way the vaccine works. And that's important because that helps us to understand why we need to test after people are vaccinated. What happens in vaccination is once you have the vaccine injected to the person, which is basically the purified heart, not the whole virus, just the heart. The detective sees this and says, and tells the general immediately, oh God, this we have an invader with a green hat. And the general tells the policeman, right, go and cuff him and make antibodies and then make plenty of a whole squadron of policemen with several handcuffs and get that ready so that in case he comes again, it tells the sniper, find this intruder and kill it. And then make a whole squadron of snipers to be able to be ready to kill this person. So this process takes 2 weeks, remember? But what happens is that even after you've been vaccinated, you can still get infected because the virus can still break in. The difference is that as soon as it breaks in, we have a whole squadron of policemen and a whole squadron of snipers that immediately attacks it and doesn't let it grow and replicate in the person. But they can still be infected, and that's why we test. So if you test a person who's been vaccinated, they're not likely to get sick. And therefore, the amount of virus in the system is much less. And Dr. Weldon will tell you that you need to zoom your telephoto lens very far to actually be able to pick up anything in a vaccinated person, as opposed to a non-vaccinated person where you oftentimes will pick that up much more readily. But we can still sometimes pick this up in vaccinated people if they've been exposed. That's the difference, and that's why we need to test. Right, so I'm going to move to travel testing now. If anybody has been lucky enough to go out of the island in the last year, you will have been subjected to this. What we do is we have a requirement that you have a test before you come, and that needs to be a PCR test. So that's a NAT type test that I mentioned earlier on for all the reasons I've told you about. And then once you get to the island, you have a test on arrival. You have another test on day 4, another test on day 8, and a test on day 14. And that helps us to be able to pick up early if anybody becomes positive with this virus. And as I said earlier on, that could be a vaccinated or a non-vaccinated person. Both of them can be infected, but the vaccinated person is less likely to be able to share the virus because the body is able to stop the virus from replicating in the vaccinated person. Right. So testing close contacts. If you've been in contact with someone who's been who's been tested positive to the virus, they're likely to be shedding the virus. And if you've been in close contact with them without mask or within 6 feet, that means that there's a possibility that you could go on to detect, to develop an infection. It does not mean that you're positive at the time, but it means that you're at risk of becoming positive. And that's why we ask that you quarantine. And the quarantine period is 14 days, which corresponds to the average time we expect that the person who's been exposed to the virus becomes positive. So what do? We test if you've been identified as a close contact. Hello?
Hi, Doc. I'm trying to see if we dropped out.
I think I dropped out, but I'm back on now.
Yes, you are. Continue.
Yeah, so that was what I wanted to talk about. I dropped out at the end. I think did you catch my discussion around quarantine?
Some of it, yes.
Okay, so maybe I should just go over that again.
Yes, I would finish up with quarantine.
Okay, right. So why do we test at quarantine and why do we test close contacts? Remember, we describe close contacts as people who have been exposed to someone who's positive with this virus, and the definition is someone who's been in contact with the positive person for more than 15 minutes, and the distance between them, because it's a person-to-person spread infection, is less than 6 feet. So if you are identified as a close contact, the contact tracers will contact you and ask you to test at the start of the quarantine and also at the end of the quarantine. And the quarantine period is 14 days because that's the time, the typical time it takes for this virus to develop in someone who's been exposed. So the test at the start is to let us know if you're already positive, because if you're already positive, you're treated differently and you're moved into isolation. And the test at the end of quarantine is to let us know if you have been, if you converted during that 14-day period. And that allows us to be able to protect everybody else. So that's why we test at the start and at the end of a quarantine period. So I'll allow the rest of my colleagues to discuss now, and then I'll take questions later.
Thank you, Dr. Ayo, Bermuda's Chief Medical Officer. I have so many questions. based on. Very informative. I have so many questions. We'll segue now into Dr. Karika Weldon. Dr. Weldon, I know you've been working very closely with the students and the Ministry of Education. Please share with us this evening.
Thank you, Tina. Just to give a brief summary of what I do, I am a biomedical scientist, and I did my undergraduate and my PhD in biochemistry. And I have been back in Bermuda for just over a year now, and lead the MDL team, which is the government layout for COVID testing, and also do science advising to the government of Bermuda for COVID. So I'm going to try to give a brief kind of overview of what actually happens when your sample is taken. I know a lot of people on the audience are probably like me, and I've had over 30 tests done. And, because we've traveled, or, we were just trying to make sure that we're safe. And you may not know exactly what happened. So I'm going to try to give you some insight into that so that you can understand the whole process and maybe get some clarity. So the first thing that happens when you go to any of the testing sites is that we actually, from that moment, put you into groups. And so if you have a nasopharyngeal or a nasal turbinate test, they get grouped into groups of 8, and those have to stay on ice, okay? If you go to the community sites, or when we go to the schools, which I'll talk to a little bit later, and you get a saliva or buccal sample done, that can stay at room temperature, and we group those in groups of 8. And we use a normal closed peg. So we repurpose some things, and we keep those groups together, and they get transported from the site to the lab in batches. So one of the key points that I want to make sure the public knows is that you may go to Peru at 10 o'clock in the morning, but your sample doesn't yet reach the lab until about 1 p.m. That will be in the first drop. And then there are periodic drops throughout the rest of the day. And that happens from all the sites, including the airport and the other community sites like Bullhead. Once the samples reach the lab, what actually happens, and this is footage, I wouldn't say live, but it's not. This is footage that we recorded of the actual lab staff. They would then make sure that your demographics on the paperwork and also on the label match. So your name, first and last name, your date of birth, and you probably may have seen you have a confirmation number and a unique ID. We make sure those all match because we need to be 100% sure that the sample we are testing is for you. So as you can see here, we have 2 of the staff here, Sharina and Kezia, that are doing this for all the samples, and this is done on a 1-by-1 basis, so there's a lot of attention to detail. Once that's done, at the same time when they are in their groups, we give them an ID, and we then make a plan about what we're going to do and how we're going to test. So you can see the picture on the right. Those are the groups that are now rolled up into these little bowls, and they go into the fridge if they're nasopharyngeal samples. And you can see on the right, this is actually a plan from today. I actually took the first run of the day. So you see we have SOA codes, those are for saliva. You see we have AA1, AA2, those are our airport samples. And then you see we start A1 and we go to A1 or to 12 and then B1 to 12. Those are our normal samples that we get from all over the place. You're also going to see we have I1 and I2. Those are what we call stat samples, or those are VIP samples. And so if you are symptomatic, or if you have to travel really urgently for emergency travel, we definitely try to prioritize those people, and that is done in the plan. And so this plan is then used for those that then go into the hood. As you can see, this staff member is underneath a glass. They already have all the PPE on, but they're also protected by a very big piece of glass that's under a hood, and that hood is actually filtering the air and taking it up into the filter on a regular basis to make sure that the air in the hood is filtered and clean. You can see that he's taking out 1 sample at a time, and he's actually doing 1 pool or 1 group. It goes into the same spot in what is called the cartridge, and between each of these samples that we're testing, we get a new tip. That's what's in that yellow box there. We have the pipette you see is just sitting in the tip box. And then we also rub down the pipette just to be sure and be mindful that we're not cross-contaminating anything. That is prepping the samples for extraction. Now, this is a pretty awesome video that I found where it's showing you really what we're trying to do. We are trying to burst the virus open. We want to get rid of everything else and want to make sure that we can see the genetic material. This is an RNA virus, and so the genetic material is RNA. And just another nice plug, this is the exact same thing that should happen when you wash your hands. So, we have to social distance and we have to keep, 6 feet, but we also have to continue to wash our hands because this is the exact process that will happen and you'll be able to kill the virus that's on your hand potentially or on any of the surfaces that you may have touched. But this process is important because we need to break open the virus so that we can see the genetic material, purify it, and make sure that we have just the RNA at the end. The next step is that we set up the PCR reaction, and it's an RT-qPCR step. And we then put it into a machine that I like to kind of call like an oven. I really like to eat and to, make food. So there you go. There's like a big oven for the lab, and we set it and program it to say, you need to cook it for this amount of time, and then it will give us a result. So we put it on just like how you put on your pie, your cassava pie in the oven and you walk away. We do the same thing. I want to walk you through a bit more what PCR is. So we're going to have a closer look at the polymerase chain reaction. Really excited to describe this to you guys because when I, used to come back home before COVID, I used to go into the schools and do outreach about PCR. So this is really exciting that I can do this on a national level. So you have your now RNA or DNA or nucleic acid, as Dr. Ayo had hinted onto earlier, that we've now extracted from the virus. That's just a bunch of stuff. It's not really telling us much. You just have a bunch of stuff there, but we want to make sure we can pick up the virus in a very particular place and see that it's there. This allows us, this process of PCR, to find and make a lot of copies of a specific part of any nucleic acid target, and it has to be DNA in order for the PCR reaction to work. Now, you might have seen the RT in front of the PCR's name. That stands for reverse transcription, which is just the process of changing RNA into DNA first so that PCR can happen. So this is our region that we might be interested in. In the lab, we actually do, our main test is looking for the E gene. So I think many of us know about the S gene because of all of the variants and the spike protein that we keep talking about. But there are a lot of other genes in the viruses of coronavirus, and we look specifically at the E gene. The test has been designed, it's very specific. It was actually one of the first tests designed for COVID, and that's the one we're using, which is very, very accurate. And so what happens is over the process of the PCR reaction, where we just let it, incubate and cook for us, it's making loads and loads and loads of copies of the DNA so that we can actually try to see it. Because you can imagine, we can't see DNA. We can hardly see a speck of sugar or salt on our finger. DNA is invisible to the naked eye. And so in order to see something, we have to make more and more copies of it. But how does PCR work? Like, what actually is going on? So I'm going to show you. There are 3 steps in any PCR reaction. The first step is what we call denaturation, or basically you're heating up the sample to really high temperatures. And what that does is your double-stranded DNA then opens up. And now it becomes 2 single-stranded new templates that you can use to make copies. So now we've denatured the sample, and you can see that was at 94 degrees, so very, very hot. Then we drop the temperature down to about 50 to 60 degrees Celsius. It depends on the design of the experiment. You have to optimize that. But ultimately, this is now the annealing step, which allows for the primers, which are kind of like the fish hooks that allow us to find that specific piece of DNA that we are looking for to bind. Remember, 94 degrees, everything kind of breaks apart. So we have to cool it down to allow it to bind in the first place. And then the last step, you take the temperature up just a bit to 72 degrees, and that's actually standard across the board for all PCR reactions. And you see you have the building blocks here, DNTP is what we call them. They are the building blocks, like the Lego pieces that make up our DNA. There are 4 of them, and we can talk about that another time, about those 4 pieces or the 4 building blocks of DNA. But essentially what's happening over time in the last step is that it's making a new copy from the template, because there's a specific way how DNA is replicated. This is what we just witnessed one cycle. You just did. So this is the cycle that we're saying happens over and over and over. And as you can imagine, the more times you do that, you're going to get more and more copies, and it's actually exponential. So if you start with 1 cycle, you're going to end with 2 after the first step or first cycle. Then you're going to have 4, and then 8, and then 16, and it's going to keep going and going and going. And if you do that 30 times, you actually get over 1 billion copies. So what's all the fuss about? Like, why are we making all these copies? Isn't that going to, make the test like too sensitive? Aren't you going to find false positives? Well, the answer to that is you can't copy what isn't there. If you start with 0, 0 to the power of 30 is still 0. So you actually get nothing. So you have to have something there in the first place in order for any type of signal to be picked up. So this is actually, again, an actual result that we got last night. This is what it looks like on the machine. This is what I look at day in and day out. This is what I do. It's become like second nature. I dream about this sometimes, actually. This is showing me 2 things, right? You're going to be a PCR expert after this. On the top, it's showing me the fluorescence, or the light that is being emitted by the reaction, because on the primers, on the fish hooks, there is some light. There's a probe that can emit some light. So the more and more copies that are there, the more and more light that will be given off. So this is our PTC, which is our positive template control, which is essentially a sample that should be positive. It should go up, and it allows us to know that the whole process is working smoothly. So you can see on the top that our positive template has worked, so that's good. But on the bottom, you're probably wondering, well, does this mean that we had like a bazillion positives yesterday? No worries, no fear. This is showing us what our internal control, which is allowing us to know that each sample actually did extract and it went through the whole process accurately, has worked. Because as you can see, everything else on this was negative. And sometimes it could just be that it didn't work, not necessarily that there's no COVID. So there's 2 targets looked at the same time. And that's the key to the whole design. So we're looking at COVID, and this is actually looking at a human gene to make sure that we're actually testing a human person, right? And so we're picking up this, and this is allowing us to say, yep, the whole process has worked, and this sample does not have any COVID in it at all. It's flat as can be, and that's good. We've had a lot more of those recently, and let's, fingers crossed that we keep it that way. And so what happens at this point is I would see this and say, okay, the run was all clear, everyone is negative, and then I would input that into the system. Now, what happens if you actually have a positive pool? Remember, we put people into groups. We would then have to retest the group as individuals. So this is an example. We had a pool G10, and you don't have a clue who that is, right? I don't have a clue who that is until we dig down into who's actually positive. So we use non-identifiers throughout the whole process in the lab. So we do G10, and we have 8 people in that group. So 1 to 8 is mapped out, and that gets extracted. That gets a PCR run. And here was the result. And we now know that it was G10-7 that was positive. And you can see that, right? It's going up. Now, when it comes to the whole cycle threshold question, right? As Dr. Ayo alluded to, it's like you need to magnify in more and more and more to see what's there. Now, the PTC, you can see, went up around between 20 and 25, right? It went up pretty early, about halfway through. We do a total of 45. Now, this sample went up around 35-ish. So we would say that right off the bat, this sample has less material than the positive control. And that's just from looking at the graph because we know it came up later on, or we had to magnify more to see it. And so ultimately, when people are asking about, okay, what about this cycle threshold? What's our cutoff? Bermuda has a cutoff at 40. Anything that happens after 40 does not get counted as positive. But if it happens between 37 and 40, we repeat it just to be sure that it's real before it gets reported to the ministry. Another big question that I get is, look, are you storing my sample and my DNA for a master big plot that we don't know about? Well, I have the answer for you. This is a very accurate footage of all of the biohazard waste that we have in the lab. When we end up testing over 2,000 samples a day, you can see the samples in some of these bags. We have to throw them out regularly. We have 2 fridge freezers, and we cannot hold more than about 2,000 samples in it in the first place. So when we start testing around that 2,000 mark, we are actually throwing away stuff from the morning so that we can test stuff at night. So we are regularly throwing these out. These biohazard bags are picked up by the awesome team at Environmental Health. They come regularly to the lab to collect this trash, and they take it to the hospital. And at the hospital, they do an amazing job of incinerating all of the biohazard waste. So none of it is stored, none of it is kept. The only ones that we will keep for a little bit longer are the positive samples, so that we can try to understand what strain they are, because we all know about all these variants. I want to make sure that we don't have any funky ones or any ones that we're not prepared for on our shores. I'm going to now finish off by talking about the saliva testing that is happening currently in the Bermuda school system, and that is in both public and private schools. The idea is that we can't logistically test everybody in every school every week. It would be a lot of testing. We would be testing the children way too frequently, and ultimately it just would not work. So we came up with a plan that we would actually try to screen randomly each classroom, around 25% of the class each week over a 4-week period. So over the course of the month, we are testing everyone, but over the month, you're only getting tested once as a child. So as you can see here, we have, for example, class 1 to 5, and you see all of those that are this kind of aqua color, they will be the first 25%, and they would all be tested in week 1. And you can see we're getting just a sample from each classroom. And the way that we approached it was we let the schools make the list, and we try to help them by saying, okay, maybe do it by alphabet. So those are the same last name of A to maybe G, go in week 1, and then week 2 is H onwards. And so they had to, break it down at what works for them. But by doing it by last name, it's very random. And we're getting like a stratified sample of just what's kind of happening in that class at that time. As Dr. Ayer mentioned, it's a snapshot. Something could change the next day. But we hope by sampling the class every week in this way, we would definitely be able to pick up anything that is, what we don't want, any coronavirus in the school. The other thing is that we recognize that some staff members and some teachers are more risky or higher risk than others. So for example, in primary school where the teacher stays with their class for all the subjects, we would deem them to be a low-risk staff and a low-risk teacher. And so they get tested also once a month. There are some more medium-risk staff and teachers. And you can see they interact with more than one bubble, because they potentially, if they were positive, could give it to someone else, right? They could transfer from one class to another. And then you have a high-risk teacher and staff. And to be very frank, that's basically everyone in the high school setting, because the high schools are just one big bubble, because they actually interact with multiple classrooms and could potentially become a super spreader. And so the strategy that was employed is that those who are high risk will get tested weekly. Those who are medium risk will get tested every 2 weeks. And those who are low risk, as I said before, will get tested once a month, along with the students who are also tested once a month. We started this out, I believe, 3 weeks ago. So this is the 3rd week of testing. We started off initially in the private schools. So this is their third week. And this week has been the first week of testing in this way in our public schools. And I have to say it's going pretty well. All of the tests are saliva tests, so it's non-invasive. Some of the children are really, really good at spitting. They know the drill. They know that they need to get it already in their mouth. And we have an awesome saliva team at MDL who are delivering this service and driving all around the country to make sure that our school system is safe. So that's all I have for you now, and I look forward to your questions later.
Great, thank you. Much respect. Dr. Weldon, much respect. Looking at all what goes on behind the testing. Thank you so much. And yeah, more questions coming. Next up is colleague, and we appreciate all the work that she does in epidemiology and surveillance. Daiwan, we're gonna go with you. Tell us about what's been going on in testing and the results there on island. You there? She's trying to share her screen.
Hello, I'm here. Can I be seen and heard? All right. So yeah, I'm going to talk a bit about testing and screening, and also give very brief information on cases and vaccination registrations among 12 to 15-year-olds, which I think will be a great segue to Dr. Nawab, who's up next. So most of you know I'm Daiwan DeRosa, the epidemiologist within the Ministry of Health, and just a bit of background.
You're going to share, right now we're not seeing your
Oh,
screen.
you can't see it?
No.
Why is it always me? Hold on.
I see you. Full screen. There we go. You're up. You're on mute. Screen is up. Oh dear. There we go.
So
there
now
we
I'm
go.
good. Yes?
Yes.
Yes. All right. So Daiwan DeRosa, epidemiologist, talking about the Bermuda situation for testing and screening and cases and vaccination registration for 12 to 15-year-olds to segue into Dr. Nawab. So within the FBN surveillance unit, we work under Dr. Ayo as the chief medical officer. I'm the epidemiologist. There's also the nurse epi, the surveillance nurse, and the surveillance officer. And we work closely with other organizations. I have included CDC this time because we are talking about testing. And I know most of us are aware that our CDC travel health notification level is at level 4, which is the highest. And they actually use the amount of testing that we do to gauge whether we are testing enough to pick up enough cases so that they know that we're not missing cases. So that's why testing is also very important and why we keep encouraging test, test, test. So Dr. Ayo talked about the different types of testing available. So we have nasopharyngeal, nasal mid-turbinate, and oropharyngeal. And those are what I consider to be testing. And I'll go into why saliva I call more screening than testing when I get to my saliva section. So here is the number of tests that are being done per epidemiological week. So an epi week runs from Sunday to Saturday. And you'll see that in the beginning of the year, we were looking at about 5,000 tests, and then it did drop off. You would remember that in the beginning of the year, we were coming out of the December outbreak, the November-December outbreak. So we do find that when we're in outbreaks, more people do go get tested, and that's also part of our contact tracing process. So around epi week 11, that's when we started to see more cases. And then 12, 13, 14, you'll see that we peaked at about 12,000 cases. And since then, It's dropped down quite a bit, but it's starting to come back up again now. So how often are people getting tested? Dr. Bowden said she's been tested at least 30 times. So she would be in that minority category of persons that have been tested 5 or more times. Most of the persons that have been tested have only been tested once, but of course, travelers are tested up to 4 times, and persons that are contacts or under quarantine will be tested at least twice, and cases are tested at least twice. So 45% of those tests were people that tested once, 41% of people that tested 2 to 4 times, and 14% 5 or more. So you get that huge number that we've done, over 260,000 tests. That actually equates to around 83,000 people, because that question comes up a lot. A lot of people doing multiple testing, so I thought this was an important slide to share. So what age groups are getting tested most? So this is the population test ratio by age group. So remember, this is the nasopharyngeal test mostly, and you'll see that the 20 to 29 and 30 to 39-year-olds, it's about 3 tests per person in that population. But in the under 10s and the over 80s, you're looking at less than 1 test per person in that population. So saliva screening. The World Health Organization has said that saliva testing alone cannot be used for diagnostic. So that's why it's considered a screening test as opposed to a screening as opposed to a diagnostic test. So here's the number of screenings per epi week. So you'll see that it's generally pretty low unless we're doing something special such as hospitality or any other special areas. But in epi week 18 is when we started the school saliva testing. So you see the big jump there. And a similar slide for the frequency of screening. Most persons have only been tested, screened once at 72%, 16% 2 to 4 times, and 12% 5 or more. And you'll see a different picture here, where the over 80 has the highest rate of population screening. And that's because we don't want to keep giving our over 80-year-olds the nasopharyngeal test. And the World Health Organization has recommended that be used to screen long-term care facility residents. So our cases in our 12 to 15-year-olds, we have had 67 cases in 12 to 15-year-olds. Beginning in epi week 11, highest in epi week 14, and a few cases in the last 2 weeks. Of those, 33% reported being symptomatic and 67% asymptomatic. And by classification, 4% were imported, 30% were household contacts of known cases, and 39% were classified as becoming infected either through school or a school-related activity or a dance class or something like that. And then the vaccination in 12 to 15-year-olds was opened up again about 3 weeks ago, and we can see that there is definite interest in persons aged 12 to 15 years being vaccinated. And that's my very quick presentation, because we want to get to Dr. Nawab to get to the nitty-gritty of the vaccination in 12 to 15-year-olds.
Thank you. Thank you so much. Thank you so much, Daiwan. And again, for all the work that you do during the week, your epi week, is that, did I say that correct? Epidemiology week?
Yeah, we call them epi week.
Epi week. And just tell people that don't remember, what is an epi week?
Yeah.
Taiwan?
Oh, and yeah. An epi week is used by epidemiologists to ensure that we're always talking about the same period of time, year over year, every year. It's used throughout the US, it's used throughout the Caribbean to know that when we mean we're in epi week 15, then across the world, we're using epi week 15, which runs from Sunday to Saturday.
Excellent. Thank you so much. Thank you so much. And now we are pleased to have joined us. And I do want to remind people, I know it was advertised that Dr. Rahman would be with us today, but he has been incredibly busy with patients and surgery and all kinds of other work. And he wrote to us and he said, I just can't make it today, but we want to thank him. He's been incredibly helpful in explaining the vaccine and explaining the reason why we vaccinate. So thank you to Dr. Rahman, who is not with us tonight. But we are pleased to have Dr. Noah, Dr. Noah, are you there? I'm understanding that we're still live. We are getting, Dr. Io, are you there?
Hello?
Yes. How are you?
Sorry. Yeah, hi. So I just dropped off for a minute. Did you want
Yes.
to ask a question for me?
Okay, so we went to go to Dr. Noah, and unfortunately, he dropped off. We really been having problems this evening with our Facebook. I keep saying, okay, he's gonna rejoin us. Look,
Okay.
I'm multitasking, Doc.
All right. Okay. Sorry.
I'm multitasking.
Yeah, it looks like Zoom is misbehaving tonight.
Yeah,
I just
Zoom is definitely misbehaving.
Right.
All right, I know we're trying to connect with him.
Okay.
He's back. We're back on.
Yes, sorry.
Are you there? Okay.
Oh.
Yeah.
Oh no.
It's a bad connection.
Yeah.
Yeah, Dr. Noah, it's a bad, not a great connection. No? All right, you know what?
Well,
Okay, yeah, good.
I think we got him.
Yeah.
Did we get him?
Yes, you did.
All right. Dr. Noah?
yes, I'm here. Apologies for the issues.
No, everyone's been having issues tonight.
Yeah.
Dr. Noah, I want you to do me a favor. For those that do not know you, I would love for you to share with us who you are and tell me, why are you in Ghana? I know you're married to a Bermudian. So why are you in Ghana?
Okay, so I was born in Ghana, left years ago, and traveled and did medicine in Cuba, training in Puerto Rico for pediatrics. Did my pediatric training in Puerto Rico and then moved to the States, but got offered a job 10 years ago in Bermuda and then came to Bermuda. I've been in Bermuda for the past 10 years. Prior to my current stay in Bermuda, I had been here before, between the years of 2002 and 2005, working at Kinedred Memorial Hospital as a house officer, as a pediatric house officer. So I've been in the field of pediatrics since 1990. 2008 and specialized in 2010 and been working in Bermuda until now. I'm currently just visiting family here in Ghana, and just on my way back to Bermuda next week.
Okay. So you're coming back to us.
Mm.
Do you work with a particular practice here on the island?
Yes, I work with Pediatrics as well as being the chair of pediatrics at the Canadian Memorial Hospital. But my full-time practice is at Pediatrics in Bermuda.
Okay. All right. I want to talk with you, and I know that, and I want to thank you. I really want to thank you for taking time tonight to come and meet with us and have a couple of conversations regarding vaccination in adolescents. I guess the big question is for most parents, is it safe? Why should a child, two questions. Is it safe? And why should a child or adolescent between the age of 12 and 15 even consider vaccination?
The vaccines are safe. I mean, it's been tested, thoroughly. And with the recent approval for 12 to 15-year-olds, just tested in almost 2,600 children of that group and trialed and actually proven that the efficacy was much higher in that group with a high antibody response, even higher than the ones in the 16 to 25-year-old group. So all the safety concerns have been looked into, and it's proven to be, really safe vaccine. I think, the reason why people question the safety, because people think, oh, it's a new vaccine and it's a new technology, which is not really, true in the sense that this is not a new technology. This technology has been used, been investigated and used in different other products in the past 20 years. Now, the urgency of speeding up the delivery of this of the COVID vaccine using this method is because of the pandemic. And so the reason why it was processed so quickly because the authorization was given to just cut the red tape and use the science behind it to give the authorization for use. So, when you look at the science behind the vaccine, the science is solid, the safety is solid, and there's no reason not to vaccinate. Now, when you ask the question why should a 12-year-old or 12 to 15-year-old or any child get a vaccine, children are one of the most impacted within this COVID crisis. The impact of not being in school, the impact of not being involved in their social activities has caused a lot of psychological damage and it will continue. And we need to get children back into some normalcy. We need to get our lives back into normal, and unfortunately for Bermuda, we have a very healthy pediatric population. We are a small population, well cared for, with one of the highest vaccination rates around the world. And so we haven't seen the effects of COVID in children as being hit hard like other places. Even in the developing countries, the cases of COVID in children are high, but the deaths related to COVID are low. When you go to South America and Sub-Saharan Africa, one of the biggest deaths or largest number of deaths are happening in South America, in Brazil, in Ecuador, in Peru. And it has to do with also underlying factors, of health in general, socioeconomic issues that are there. We don't live in the same kind of conditions of multiple people sharing, multiple families sharing one home and spreading disease as much as we in those countries are. So vaccination has always been one of those things that promote and encourage as part of a healthy population. And we have been lucky that we don't see a lot of diseases in Bermuda because we've been able to vaccinate our population against those diseases over time. And so when we look at the health of our population, it's not just how good we live, it's how good we protect ourselves from falling ill and how good we are in not discouraging the spread of disease by vaccinating. Now, one of the main reasons for vaccinating children is that although children have a less incidence of severely suffering from COVID, there are rare incidences of severe cases of cardiopathies, long-term effects happening in children who get COVID. Now, we might say, well, it's a small population, but it's still, no child is born in this world to get a disease and die. No child is born to die. So we have to protect our children, and part of that protection is making sure they're healthy, giving them the strong base of good nutrition, a good sound body, a sound mind, adequate care, and part of that care includes vaccinating.
And I appreciate that, Dr. So, and I appreciate that, and we're going to open up the whole panel discussion now. But I want to ask you this question. But still, as a parent, I want to know, what are the risks? There's got to be some risk associated with this. That's the fear, that there is the big risk. Yes.
The risk for this vaccine is very, very minimal. I mean, we've now vaccinated 16 and above, and we haven't seen any severe cases worldwide of any kind of risk involved in the vaccination. Now, any vaccination that you give will always have some kind of adverse effect, that you have pain, you have soreness, and especially with this COVID vaccine, you might get a fever. It happens with all vaccines because you're trying to induce a reaction, an immune reaction in the body. And so when you look at the science behind the vaccine and the way the vaccine works, you're not introducing a virus, a live virus into your body. You're introducing a protein which is inducing your body to produce antibodies. So the effects are really very minimal. The side effects are those minimal things that we see: a mild fever, aches, soreness on the site of injection, and nothing worse than that.
Some would say that we are trying to vaccinate children because they are the asymptomatic carriers of the virus. What do you say to that?
Anytime a virus enters somebody who's not vaccinated, you have the chance that that virus will mutate, and that person will be a carrier and can spread it to the most vulnerable people in our society. So if even that child doesn't get sick, and the rare cases, the rare cases that a child gets sick, but also there are very rare cases that a child who gets sick will get severe complications, especially in this kind of our first world which we live in. When you go to the third world, that doesn't play out. You have a majority of people getting sick. You have more people getting complications. But even in our society, where we are healthy and well cared for, when we open that portal of a child who's not vaccinated to catch the disease, that child has the potential to go to school. Even they are asymptomatic, they'll spread it to other children. Now, amongst those other children, we might find you have who are immune suppressed, or who are on some kind of going through some health issues and requiring chemo or requiring some kind of long-term immunosuppressant medications. Those then become at risk of severe disease because they cannot mount the same immune response as a healthy child. Mm-hmm. So by vaccinating the healthy children, you're protecting the ones who need most protection most in our society, who are the weak, who are the immune suppressed, who are the ones that have medical conditions that doesn't give them a good immune response. So within the context of saying, well, we given vaccinations, we help in not one, to avoid the spread of disease, and two, to avoid a mutation of a virus that then can turn into something a little bit more dangerous than we cannot cope with.
Yeah. Yeah, I'm gonna ask everyone to turn their cameras on now because I'm gonna throw it out. Thank you, Dr. Noah. Thank you, Dr. Noah. But we
You're
got
welcome.
more questions coming, and I think they're gonna hit Dr. Io in terms of, we've had a couple of families that have written, and I'm gonna read exactly what they've said for you. If a child is 15, goes 16 beyond the beginning of August, are they able to get? Mhm. If a child is 15 and 16 and goes 16 beginning in August, are they able to get the Pfizer vaccine before it's phased out in June? And then someone else wrote, I'm just wondering how soon do you think we can get started given 12 to 15? So that's two questions. Will this 50-year-old be able to get it before they turn 16? And then two, when will we finally see the 12 to 15-year-olds?
Yeah, thank you, Tina. I can understand the anxiety of parents to get this done as soon as possible. Unfortunately, we are hampered by the fact that all our Pfizer vaccines have been given to us by the Foreign, Commonwealth and Development Office of the United Kingdom, and we have a memorandum of understanding on how we can use that. All of that is indemnified through the UK government, and that indemnity only applies for people who are 16 years and older.
Mhm.
So it's quite unfortunate that we can't get that done now. The UK government, the UK MHRA in the UK is not yet approved this for the 12 to 15-year-olds. They have all the data and they're taking their time looking through that. But Health Canada has approved it. The FDA has approved it, and as Dr. Noah mentioned earlier on, this is based on the trial data that looked at well over 2,000 people and 2,000 children, and it was found to be 100% effective at preventing severe disease in those children. So coming back to Bermuda, because our vaccines come with strings attached, we can't give it out yet. However, we're working, burning both ends of the candle to make sure that we get the approval that we need to be able to give this out. If for any reason we're not able to give it before the present stocks expire, we will do our best to make sure as soon as we get the MHRA approval, we get some particularly for the parents who really want this for their children.
That said, one of the other questions that came up was, and I know that Dr. Noah touched on it, but it was about the adverse reactions. There was a very sad story on American national news about a young woman that died as a result of having it. Tell us about those adverse effects from the COVID jab and the reported deaths. Again, parents are concerned. You're hearing these stories on national news out of the United States or the UK, and talk to us.
Okay, so the first thing I say is that when people share information, you need to find out who is sharing that information and what motives do they have about this. So yes, there may be association. That's not the same thing as causation. So if somebody who unfortunately passed away after they've had this vaccine does not necessarily mean that that was directly as a result of the vaccine. I'm not familiar with the story you talked about, but looking at the data that has been shared through official sources, there is an adverse incident reporting system that investigates every side effect that is linked to the vaccines. Now that has not come up with that age group. So that's not, so we would, once that investigation is complete, we'll be able to know whether this is as a result of the vaccine or not. But it's, from what I know of this vaccine, it's extremely unlikely that that's the case. So Dr. Nawab did mention earlier on that the side effects to expect from this vaccine in children is not any different to what you expect for adults. It's about arm ache. It's about a little bit of fever. Occasionally, you might have might feel a little bit worse for wear, particularly after the second dose, but that lasts less than 24 hours. And that's an evidence that your body is reacting well and producing the immunity. Remember those policemen and their handcuffs? Remember the sniper and the guns? Your body, the general, is telling the policemen, make plenty of those. The snipers, make plenty of that. And that's what's causing the fever.
Yeah. And I appreciate that. And I've got other conversations, but I really feel like we need to sit here for a moment.
Okay.
Parents are writing and they're saying, you know, teenagers, when this all started, everyone said, oh, the young people, don't worry about them. They ain't gonna get it. It's the old people we gotta worry about. Now, all of a sudden, it is, oh, teenagers, babies, children are going to contract it. Why are we putting so much focus on doing it in schools, testing in schools, and then, you know, now looking at vaccination for children?
Yeah,
for everybody. I want Dr. Weldon, Dr. Noab, and I also want Dr. Io to weigh in on this.
Yeah, I'll quickly start and I'll let my colleagues come in. And Daiwan showed a slide actually that showed that this virus, this nasty virus, is no respect of age. Every age group gets this virus. Why do we test in schools? Because we want our children to be able to remain in school with face-to-face learning for as long as possible. When we test, we then know who's positive, who is exposed, and we can narrow down the people who are exposed and exclude those from school. What we want to avoid is a repeat of what happened last year, where we had whole school closures. That is not good for children's mental health. That's not good for their education. We need to be able to be more intelligent about this and make sure that we find out and protect our kids by testing them regularly, keeping a surveillance, watchful eye, identify those who are positive and remove the small group around them. And the schools actually get this. There is more working in bubbles now. Classes, the bubble size are based on the classes. So if you have a positive person, we know it's a small bubble, we need to exclude. We don't need to close the whole school and disrupt children's education and have negative impact on their mental health.
I hear you very clearly on that. Karika, Dr. Weldon, sorry.
I'll add to that. I think, like as Dr. Ayers just said, we've had a very good close-up experience of this. Literally feels like it's still happening. My heart's still pounding and thinking about it. It was just a couple months ago, literally just in March, when we had massive outbreaks in our schools. And as Daiwan showed, majority, 2 out of 3 of the children were asymptomatic, but were still infectious. So we're giving it to school, their school friends, didn't even know that they had it. And then by the time we realized, because these, 1/3 of them were symptomatic, we checked. And I remember very clearly that day. I remember the 16th of March, because it was a very, very impactful day. There was like 11 people at one school that were positive, and I was just staring at the screen like, what is this? Because we hadn't experienced that last time. In the first outbreak in December, it was, count on one hand how many in the school system were affected. But this is what happens when you get new variants that are more transmissible, right? And it's been shown that the UK variant is like a silent assassin in children. And, we don't want that to ever happen again. If you look back at the data, we had obviously the initial kind of blip in cases, and then it went really quiet for like 2 weeks. And I thought, okay, it seems okay. And then that's when, in March, we had the explosion in schools. And really what the issue was is that we weren't testing enough in those initial 2 weeks when we thought it was fine. And, it was a bit too late by the time we got there. What they say, the cart had bolted, or the horse had bolted before the cart. And we were just kind of like trying to get a handle of it. We're back to a good place now, and we don't want to be reactive. We have to be proactive. And the way that I like to kind of, I guess, give an analogy is with our travelers. We are the most stringent in the world, but we made sure that, we're not just going to test you or you get a test before you come. You're not just going to get a test when you get here. And you're not just going to get a test on day 4. We're going to test you on day 8 and day 14 too, just to be sure, because we just don't want, any type of spread to happen. And in a similar way, we don't know unless we test. And so that's why we've approached the schools and the public school system with this program, and they've taken it up, and it's working really well. At least you have that snapshot each week that we're fine. But I mean, we've seen it. Children were like the catalyst in our outbreak this year.
Well, Tina, I'll speak to that in the sense that part of that being proactive is vaccinating. And so what you're doing is you're building, I always tell, I do use this analogy that you cannot go into a fight without having to train properly. You cannot go into a fight without knowing the techniques of your enemy. You will never be successful in any kind of endeavor if you don't study, if you don't prepare, if you don't train. And so part of that vaccination is training our children's body to be able to fight this. We need to come back to some normalcy. Now, if we don't do that and we have more incidents of disease, then when the pool gets bigger of people catching more disease, then you have a higher chance that the children will start ended up in ICU and dying, because your volume of infections increases, your volume of complications will increase, and your number of deaths will increase. So preventing disease is all about avoiding morbidity and mortality. You want to avoid people getting sick. So if you have a class of 100 and none of them have been vaccinated and one person gets sick, you have the possibility that those 100 are going to get sick. Now, maybe 70, 80% of them will survive without, will be asymptomatic. The next 10% will be symptomatic without, and fight the disease and get over it. But what about that 10% who might end up getting complications, long-term complications, cardiac complications, and the 1 or 2 who end up in a pediatric ICU and probably not make it? No child deserves to die in this modern world. I'm not saying any older person, but children are supposed to enjoy and life and grow. And our job is to protect them. So when we work in the pediatric world, our goal is to make sure that a child is born and grows, has a healthy growth, not just physically, but socially and psychologically and mentally. Now, we've closed schools for so long that it's affected, the kids psychologically. We're lucky in Bermuda that children can have access to remote learning. But there's so many other places in the world where, and even in Bermuda, there are certain cohorts of children who don't have access to computers or laptops or internet or Wi-Fi. And these children will not be able to even go, and then you have children who don't have siblings to play with. So they're isolated. The trauma of isolation and the trauma of not being involved in any kind of normal activity has long-term effects in the child's psyche. And we at some point we have to say, look, when do we want to get back into our society to some degree of normalcy, where we have to just say, look, what, let's get these children vaccinated, let them get them to school, let them have a normal life. And that's what, we say that medicine and health is just being proactive. You cannot be reactive all the time. The success of every health system is prevention. It's having the basic primary care secure and solid. And the only way to do that is to be very, very proactive in every kind of basic healthcare program that we have. And part of this is, testing, vaccinating, and preventing disease.
Agreed. In terms of vaccination, in terms of the hesitancy when it comes to my babies, my children, there is serious hesitancy. Be interesting how you handle that as a pediatrician, but I'm not going there right now. We're not going there right now. We're going to switch over right now to, in terms of testing. Dr. Weldon, you said it. We are so stringent in our testing here on the island. Even for vaccinated, I know Dr. Io talked about it, but I'm like, for vaccinated folk, what are we doing? Why are you testing me? You told me go get vaccinated. I went and got vaccinated. Why are you testing me? So, and for poor travelers, you talk about the PRC test.
PCR.
I know it's the PRC test.
PCR.
I know it's the accepted, approved, the most scientific, is that the word, or accurate?
Gold standard, yeah.
Gold standard, okay. But you can't afford it if you try to get it. We are blessed in Bermuda that we do get it all the time. Just talk about the testing and why particularly people with vaccinated already need to test and test.
So the first thing I want to touch on is that very good point that in Bermuda, I think we might be, I haven't checked all countries, but we might be the only country that gives away free testing for those that are about to travel. I think I have, some relatives and friends that have traveled, and you gotta, cough up some bucks for it, but in Bermuda, I think we are blessed, and it's part of the strategy of the pooling that brings the cost down and has allowed us to really stretch our resources and to still be accurate, but to be more wise in what we have to do the testing that allows it to be free. So, I think that's worth mentioning. As far as how long are we going to keep testing fully immunized persons, I think if we were in a world where every country was at a place where we were reaching, close to herd immunity, and there wasn't this fear that there could be a possible new variant created somewhere else, then yeah, maybe we could get to a place where we're not testing as much. But we're a global economy, we're a global world. We have a speaker who's in Ghana. We travel, and Bermudians love to travel. That's like a genetic trait, I think, of all of us. And so we need to be very careful, because you can go and pick up a variant. And, it's been brought up by some people I've spoken to, you might be asymptomatic. It's supposed to obviously make your symptoms less. You might not know you have it, and then you could be spreading it. So the only way that we would know or not is to test you. So until we get comfortable that the world status is okay, and that we're not risking, importing some crazy new variant, then we're going to test. I mean, I'm feeling it. We're seeing air arrivals this weekend is hitting high numbers, and that just quadruples when you start talking about the retest. But it's better to be safe than sorry. I think, that's just the way and the position that we've taken, is we'd rather know than not know. And it's not uncommon, that it's been reported everywhere, really. There are some people who are fully immunized to a positive, and some who are infectious, and some who still end up in hospital, and some, so it's not 100% as well. And we don't really want to take that small percentage and run with it, because it might just happen to us. And being a small island, everything is magnified. So we would rather just test you, know for sure that you're fine, and not really leave it up to chance.
But just to make a little note on that too, because I think we all feel that when you get vaccinated, you're 100% in a bubble wrap. Now, vaccination makes your body produce antibodies, but not all of us have a robust immune system. So, you don't know how much percentage of the efficacy that you have in you. And so the studies show that if efficacy is high, because these are healthy individuals that were using a broad cohort of, tests, but each and every individual will mount a, different response of antibody levels. So still, even if you're vaccinated, I'm fully vaccinated, I'm traveling at the airport, I still wear my mask. I go everywhere, I wear my mask. I got tested. I got tested on my arrival at the airport here, and before I got my bag, my result was back. And if I had tested positive, I've been in quarantine right away in a different location. So it doesn't matter where you get, you are vaccinated. I still think that until we reach that herd immunity where we feel that, well, at least the healthiest population, number of people in our society who are mostly healthy can protect the weak. And then we can say, well, we've reached that amount, we will lessen our testing and surveillance. But we still have to be vigilant. We still have to survey. You cannot say just because you bought the newest alarm system, you keep your doors open. It could be the best technology ever, but the thief will still find a way to get into your house. Yeah. So you still, protect yourself. So it doesn't give you, and I mean, it doesn't give you a bubble. It doesn't wrap you in a bubble. It just gives you the opportunity to fight better. So when you can train your soldiers, but not every trained soldier will perform at 100%. That's why you have the green berets, and you have the special snipers, and you have the paratroopers, and you have the base soldiers. You always have to make sure that you opt in for the best. And so at my age, although I've been vaccinated, I say, look, I'm not as young as I was before. I cannot go carefree. I still have to wear my mask, wash my hands, and take all the necessary precautions because I'm not a 26-year-old. My immune system is not a 26-year-old anymore. Mm-hmm. I can't take that risk. And that's how we have to look at life. It's all risk mitigation and risk control. And part of increasing your chances of being able to mitigate that risk is vaccination. Mm-hmm. So from 0 antibodies that you have, you get a bit more. That's good. Now, you don't have to fall sick to produce antibodies because you don't know how you're going to cope with that sickness. Person A will get a sickness and not do well. Person B will get a sickness and walk through. Person C will get a disease, fight it, and then 6 months down the line, they have a complication from COVID.
Well, one of the questions that came through was that variants are possibly linked to vaccinations as the virus mutates around those antibodies. That's just something someone read.
I can address that.
Yeah, go ahead, Doctor.
Okay.
Dr. Aya, go ahead.
So the link between mutants or variants and vaccination is actually the opposite of what you've just described. Okay. Because if you're vaccinated, remember, you already have your policemen with their handcuffs and your snipers at the ready. It doesn't mean that the burglar cannot break through, but as soon as they break through, you have all these people mopping up and killing it. It does not allow the virus to multiply in your body. People who, however, have not been vaccinated, once the virus affects them, it runs riot. And what do viruses do? They mutate. They always change. They always change. Most of the mutations is harmless. It doesn't cause you any harm, but occasionally it selects because your body is constantly fighting against it. The ones that are the deadliest are the ones that manage to survive. And therefore, you can actually be that vessel that creates the variant of concern because you've not been vaccinated and the virus has had the opportunity to run riot in you. So that's what actually happens with mutations and unvaccinated people. If you've been vaccinated, because your immune system largely, as Dr. Nawabas mentioned, is able to deal with these viruses, then you are less likely to grow something that causes problems for everybody else.
If I can add to that as well, Tina. So when I was describing how PCR works, and I had that slide that broke down the 3 different steps, and you had the elongation that was making more copies. Actually, PCR is essentially just like a test tube way of what actually happens in the body when DNA is replicated. So it's mimicking the actual process that happens when your body needs to make 2 cells, needs to make 2 versions, and then it splits into half. That's exactly what it's replicating. And that's the same process That also happens when a virus is mutating and when a virus is making more copies of itself. It needs to copy its whole genome and then it can make 2 copies of itself. And then it has to copy that. So it's the exact same process that happens in nature. Now, the polymerase, and if I can I quickly just put my screen up again so I can show that? Just so I can give a bit of a image here. So I talked through these steps of PCR. I want to focus on this step. This Taq polymerase or DNA polymerase, there are many different types of these enzymes that actually do the replication in your body. So this is just one version. It's a Taq because it can get to really high temperatures and not start working. But this is the culprit. This enzyme here, and enzymes are like, what allows us to chew, right? We have some enzymes in our mouths that allow us to digest. That is just a type of protein. This thing here is not accurate. It will sometimes, it's supposed to match, you can see here, if I press this, it's supposed to match the red with the purple, and it's supposed to match the green with the yellow. Sometimes it doesn't do that. Sometimes it will take a green and put it with a purple by mistake. And so that is when a mutation is introduced. And just as Dr. Ayo just mentioned, the more times you have copies being made, that probability that it's going to add the wrong building block goes up because there's now more chances that it can happen. So being vaccinated, actually, like Dr. Ayo said, it keeps the risk of producing these new variants down because you don't allow this process to happen, really, because you're killing it once it enters your body.
Sorry, I'm so busy listening. Couldn't find it. And I want to go to that. We're going to get ready to wrap up in a few moments, but I want to, that question, I want to go back to the question about testing and how we've stringent and been so stringent on our testing. Did I hear you, Dr. Ayo or Taiwan, talk about that we have done in Bermuda, we have executed or administered more than 250,000 tests?
Yeah, that's correct. Actually,
Wow.
it's much more than that because if you take into account I think this is looking at persons. If you take into account the number of times that single people get multiple tests, so we're talking of multiples of that. Really, it's a phenomenal amount of tests we've done.
Yeah, huge. I was blown away when you said that. Taiwan, how are we doing with the young people? Did you give a stat, if I remember correctly, in the younger generation? And then I want to go to those 20s and those 30s, that 20 to 40, I believe the Minister of Health showed a graphic. That's the lower percentage in terms of testing or vaccines. Does anyone remember? Go ahead.
Sure. I had showed a graph of the population testing ratio. So we take the number of people in that population, in that age group, and we look at the number of tests performed in that age group. And it's actually the 20 to 40-year-olds that are the most tested using the population test ratio. And then the under 10s and the over 80s are the least tested using the population test ratio.
Wait, say that again. Sorry.
The under 10s, under 10s and the over 80 are the least tested using the population ratio.
So now, what about vaccines? If I remember correctly.
The opposite. So of course, and that's partly because of how it was rolled out. So it was rolled out to the 80 and over first. So of course, they have more opportunity to get it over the past 18 weeks. And then it's just opened up to those in the under 50s in about the last 5 to 6 weeks. So it will be an inverse thing there.
And I hear, and everyone keeps talking about understanding the variants that are out there. What are the dangers for us in Bermuda in regards to the variants? We're very stringent on our borders. what are the dangers to us, to all these various variants? Anyone want to touch on it?
I can start on that. When this most recent outbreak started, we didn't have a clue what variants we were working with at any point. We obviously knew people were positive and we had their positive results. I think it was around beginning of March when we actually tested all of the samples from the previous one in December to see what those variants were with the rapid PCR test. And it came in handy because then we were able to quickly identify, I think it was about a few days before the initial sequencing came back from CARFA, that we had the UK strain here. Now, initially, we didn't know that that would change the ball game. We thought, oh yeah, we know what we're doing. Yeah, we've got this virus under control. But as cases started to rise and as, more people started to become positive, and we started to see some weird trends rise, and you started to see more people later on in their quarantine are converting, or more people on day 14 who were close contacts were converting and having a longer, their own incubation period. We started to realize, yeah, this virus is a little bit different. This variant is different and we have to change our approach. And you might see if you go back that we put the brakes on a lot quicker when we realized that this variant was a bit different. And had we known that from the beginning and what it came with, I think we would have hit the brakes a bit harder. And that's obviously, in hindsight. And so now we are in a position where every single positive sample that we get at MDO, and we also have a partnership with 2 of the other labs, they send to us, we do the variant test so that we can make sure we're keeping track of what's going on. And in a good way, everyone in this outbreak was UK, so we knew that it was just, the same strain going around. And now, I think as of this week or the beginning of next week, we should be able to now be picking up for these newer ones, the Indian variant, so that everyone that comes in, we can just make sure that we don't have any of these newer.
Oh, wait. What do you mean? We may be
we're going to have the ability to test for it because at the minute it was new. It was just, it came up since we had this test. So we've reached out, we've got the newest version. We're going to have more tools in our toolkit and we'll test for that as well. So that we know as soon as what any new variant we may have, and so we can adapt the policy. And I think that's been the learning curve of everyone in this outbreak.
Yeah, I think that's been worldwide, though, I'm sure. It's been a learning curve for everyone in terms of trying to, do all the testing and everything, and the whole vaccination. So I'm going to wind up with this. And this was for Dr. Aya. So 12 to 15-year-olds are ineligible, right? And then for the vaccine, correct?
Well, we're not offering them the vaccines just yet.
Right.
Yeah, we're not offering them just yet.
So a couple of mothers, because I know it must be mothers. I'm just speaking as a mother. They're saying, well, why do we have to wait for England? Why can't we just go to the United States? Why can't we go to the vaccine providers and just bring some vaccines over here so that their children, there are parents, believe it or not, there are parents that really want their children vaccinated and believe in vaccines. Did I say that like it was almost impossible?
No.
But I get questions all the time. I mean, I'm away and I'm still getting my parents, WhatsApping me and asking me the questions. Yeah. And parents are saying, look, and I'll sign a form and, and I'll take responsibility and I want my child vaccinated, even younger children below the age of 5, because they know that the studies are ongoing. Right now, there are studies going on for the 5 to 11-year-olds and the 6 months to 5-year-old studies are ongoing on. Now, in every crisis, I always have to see the silver lining. And this COVID crisis has shown us how we can do things better, like how we've done in Bermuda, how the world can act quicker and faster, and how we can really change the world with these new technologies. Now, this technology for this vaccine has been in existence for 20 years. But we've not done this. This is the advent of a new technology that will change, revolutionize the vaccine world. This is like the Formula One. It's like we've come to building the Porsche for Formula One racing that we want for the vaccine. I mean, imagine that you can, give a child just one vaccine and don't have to give them 2 or 3 boosters for the whole first year of their life, because the technology is safe, it's effective, it's efficient. This is the advent of a new beginning when it comes to the science behind vaccines. I'm just happy and excited that this vaccination is going to translate into more using this technology to produce vaccines against not just the common diseases that we've been vaccinating against to perfect it, but also the forgotten diseases that are around in the world, leishmaniasis and other severe malaria. I mean, I just met a buddy of mine, we were talking about it, and he's like, they're already looking into investigating, using this technology to produce malaria vaccines. And so within that whole crisis of this COVID, that silver lining is that we are becoming better, and we're going to be a better world after this, and we are improving what we're doing, and the technology is perfect, it's awesome. I mean, nothing is perfect, but this is as good as it can get when it comes to the technology behind the vaccine.
Dr. Aya, did you want to touch on that?
Yeah, absolutely. Dr. Nawab is absolutely right about the vaccine. So your question is about why we can't get different sources of vaccines to give to these children, and why do we have to wait for England? I wish it was that simple. It's not something that we can just write an email to the manufacturer and the next week you get a plane load of these vaccines. We need to understand that we are in an extremely privileged position in Bermuda. We are one of 10 countries that have, less than 10 countries have vaccinated 50% of their populations. It is an extremely elite group that we are in. And that's because we've been able, due to the generosity of the UK government in getting these vaccines. It's hideously difficult to get orders. Many of the people who are just putting in orders now have to wait till 2023 or 2024 to get vaccine deliveries. Capacity to manufacture vaccines is extremely limited across the world. So why am I saying this? We have vaccine stock given to us by the UK government, and that allows us to be able to vaccinate our population. To be able to do something different to what the UK does requires us to have the permission of the UK to be able to do it. Unfortunately, in spite of everything we've done so far, we've still not been able to get that permission. But be rest assured that all efforts are being made diplomatically and through the medical community to get that permission. And I hope that in the not too distant future, we'll be able to get that permission, and we'll be able to give the parents, and I'm not going to say mothers, Tina, because fathers too are interested in this.
Okay, all right.
In less than a week of advertising this, we've had 800 parents putting their children's names down. So that's almost a third of the eligible population already within a week. So there is pent-up demand. We understand
That's
this,
amazing.
and we really would like to meet that demand, but we're just hampered by those regulations that we need to follow.
Yeah. Dr.
Just one more thing.
Dr. Noab, I know
Dr.
Noab, I know you've done work in the past with the Ministry of Health, Department of Health, in terms of bringing people on an island to talk about the importance of vaccines overall. So that's good news that you've got, over 800 parents already saying.
But we also, I mean, we have vaccines that we don't want to let go expire with their use. And so, I mean, parents, people who are still on the fence, jump on it and get it. I mean, you have sports events being organized in the states where they've achieved massive vaccination. People are getting back into normal life. after having vaccine. And we need to get our young people back on the streets. We need to get, our older folks back in the parks. We need to, the adult population who are eligible, please go get it. Until we get that authorization, we still have vaccines that we need to give. And we have people who are still on the fence and hesitating. We've had, we vaccinated. So we started vaccination in Bermuda in January. We're already close to June. So it's been 6 months and nobody's grown any extra ears or extra wings or, we've not mutated. I mean, I was hoping that I could mutate and grow some wings, but I would have wished for that,
Nothing happening here.
So
No wings.
Let's go get people to get a vaccine. The 800 parents who are waiting for their children, I commend them, and we wish, as Dr. Ayo said, I wish I would just be there, vaccinating these 800 children if we had to, but we don't have the authorization. So we'll have to be patient. Mm-hmm.
Let me ask you this though, and I don't want to put you on the spot, but you are our resident pediatrician right now. If a parent comes to you, they are adverse to the vaccine, what do you tell them as a pediatrician? Is that a fair question to ask you?
Yeah, I mean, I try to encourage and discuss, and some people just don't have the information. So I try to give them the information and break down and explain to them. And, I stand up for my background. I was born in Africa. I mean, I grew up here in Ghana. I had friends in school who had polio and were, had no use of their limbs. I worked in Cuba before the advent of many of the meningitis vaccines. And when I was a rotating student in medical school, we used to just do a lot of lumbar tabs, diagnose a lot of meningitis cases. With the vaccines, these cases have dropped. I was in Cuba when Cuba started making meningitis vaccines and hepatitis vaccines. And, the cases of hepatitis-induced liver cancer dropped massively. And so, it's not that I'm old, but I've been in places where I've seen the devastating effects of non-vaccination. I've seen children die from tetanus. I've seen older men, farmers, suffer from tetanus being admitted under my care. So when you see those things, it impacts you. You realize that, vaccination is important. So when a parent comes, I try to talk to them and encourage them. And every time they come, and I have patients, again, every time they come, I keep on, giving them information bit by bit. I give them my number. I say, look, when you leave here and you sleep over it and you have any questions, WhatsApp me, call me. I'm always accessible for information, and we can discuss further. Now, there is a certain number of people who are just plain adamant, which you can't convince. I'm not here to, try and convince those who doesn't want to get themselves convinced, because we are not forcing anything on anybody. We are trying to give you information. We're trying to make you make a choice with an informed decision based on the science and the facts that are there. And so it's my duty that if I know the facts and I know the information, why would I withhold it and not offer it to you and say, let's have a discussion about how to proceed, Then if you tell me no, then I say, okay, fine. I did what I had to do. I did my best. But we can't oblige people to vaccinate. Yeah.
And you know what? That's a good way to end. I couldn't think of a better way to end. Right, doctors? All the doctors, Daiwan, what a good way to end. I mean, realistically, all you can do is present the facts. You can't sit and argue the facts. And we don't want families, one side of the family, to be against the other side of the family. We just want to present the facts. And that's what we've done tonight. I thank you. Listen, but Dr. Ayo, you have a new fan base.
Really?
Let me tell you, Dr. Ayo, I got someone that wrote and they said, can Dr. Ayo tell us what his name means? Or I said, wait a minute. This ain't his show. This ain't Dr. Ayo's show. You've become the chief medical officer that people want to know more about. Ask Dr. Ayo. So Dr. Ayo, anything you want to wrap up with? Because we all love Daiwan. We love Dr. Weldon. And Doc, I want to tell you, seriously, your presentation tonight, I give you enough respect. Amazing work that you and your team are doing. Amazing. Thank you. And thank you, Daiwan. Nice to meet you, Dr. Noah, I don't have babies anymore. So nice to meet you in the PD.
Same pleasure is mine.
Stay there, Dr.
And,
Ayo. I'm coming back to you. And safe travel back to Bermuda. We'll be glad to have you back on the soil. And we appreciate you. We miss Dr. Ramon. Thank him for his support and bringing us the green hat, the sniper, and the police. But Dr. Ayo, apparently this is the last question. What does your name mean?
Oh, okay.
Okay.
Right. So like Sylvanus, I was born in Africa. I was born in the western part of Nigeria. It's the Yoruba people. And so my name is actually, that's a shortened form of my name. My name is Ayola. And my full name means the joy and the wealth that a child brings to the home.
What a beautiful.
So my dad really he was an older dad and decided that I was going to bring him joy and decided to name me that.
Oh, nothing else said. That's it. I'm naming my children Iola. That's it. I'm not gonna have it anymore, but I'm gonna name them that. Doc, thank you all. Obviously, you've got a fan base, and we will do one more, I believe. Yes, Dr. Aya? Yes.
Correct.
We'll do one more down the line, but I thank you all so very much. I want to thank my colleagues, Adaraka, Al Seymour, Omar Gilbert, who are working behind the scenes to make sure this stayed live tonight. Thank you all. Have a pleasant evening.
Thank you.
All right. Take care.
Bye.
Bye.
Bye, everyone.
Bye-bye. I
Bye,
think it's
everyone.
past my bedtime.
Yes.